now that the derivations are done, let's do a question. So the question is, calculate the acceleration of the car. Now we are given that the acceleration between these two positions is constant and it is not changing. We're also given the displacement s. We're giving the final velocity and the initial velocity, which is 40 meters per second and 80 meters per second. What we need to find is the acceleration. So acceleration equals to question mark. So now which formula can we use? So do we have time given anywhere in this equation? No. So we can't use this one because it has time, nor this one, or this one, or this one. That leaves us with only one equation, which is v square equals to u square plus 2as. So let's write that down. V square equals to u square plus 2as. Now let's input the values. V is the final velocity, which is 40 meters per second. 40 square equals to u, which is the initial, 80, plus 2 into a, we'll write as it is, into s. Now here's the confusing part. S is given in 100 centimeters. You need to ensure that you convert this into meters, otherwise you'll get a wrong answer. So centimeters to meters is 100 centimeters equals to 1 meter. So I'll write 1 over here, right? Now let's further solve this. We'll get a as minus 2400. Now we know this is right because as we can see, the car has a larger speed, and then which is decreasing to 40 meters per second, right? From 80 to 40 the speed is decreasing. That means that the car is decelerating. But the question is asking for acceleration. So what we do is we just add this negative sign over here, which denotes negative acceleration, which is also deceleration. Okay, so here's the next question. Find the time it takes for the ball to fall to the ground. This ball is momentarily at rest. A man throws the ball down. We need to find the entire time it takes for the journey for the ball to travel 100 meters, right? So let's jump to the formulas. Which formula can we use? So now we need to find the time. T equals to question mark. So it has to be a formula which has time. It can be this, 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 or this. This one is eliminated, right? What else? Do we have velocity? The final velocity? No. So this has v, final velocity. We'll cancel that out. This one and this one. That leaves us with only one formula, which has s equals to ut plus half at square. So let's write that down. At square. Let's input the values. S, which is the displacement, is given as 100 over here, 100, equals to ut. Remember, if the ball is falling at rest, its initial velocity is always going to be 0 because it's not moving. So we'll write that as 0 into t plus 1 over 2 into a, which we do not know, into t square. Actually, if this is on Earth, then we can take a as 9.81 if this is happening on Earth, right? So I'll write 100 equals to 0 into t is 0 plus 1 over 2 into 9.81 into t square. The 2 is going to go to multiply on that side, so 100 multiplied by 2 over 9.81 equals to t square. We further solve this to find the value of t. T equals to 4.52. Okay, this is the second question solved.